Hello and welcome back to Data Science for Humans. This is part 3, Basic Data Cleaning. I'm your host, Elias Perunen. And last time, in our last video, we looked at CSV files, learned how to rename columns in our Pandas data frame, and learned how to save that data frame back out to a CSV. In this video, we're going to look at doing some basic data cleaning. Specifically, we're going to turn some rows from fully uppercase into title case, strip out some characters from some strings, and start to look at data types. Let's jump right back into the code. So last time we met, we saw here that we read in our data frame from CSV, we renamed our columns, and we saved that back out to disk. Let's take another look at our data frame for a second. Just to visualize exactly what we're going to do, we're going to take this region column and this admission type column and turn this from all uppercase into title case. That is, the first character will be in uppercase and the rest will be in lowercase. We're going to take the fiscal year column, strip out the FY and the 06. So basically take out the first two and the last two characters from our fiscal year column. And finally, we'll have to do something with this count column because you might have noticed that it's not quite right. And why is that? Well, notice how we've got this checkbox column min max and it's checked. Normally, when Python and Spyder is dealing with a numeric data type in a column, it will highlight the rows that have the largest value and the smallest value. But notice how none of these rows are highlighted. Why is that? We'll get back to that in a minute. The first thing we're going to do is modify our region column to be title case. So how do we do that? Well, we're going to access our data column, data 2428, and with open and close square brackets, we're going to say region. So we've typed in data 2428, open square bracket, quote, region, quote, close square bracket, and we're going to set that equal to, now check this out, data 2428, our region column, dot str, dot title. What's going on here? Well, what we're instructing Python to do is that for every row in our data frame, for the region column, we're going to access the string and convert it into title case. Let's run this code. If we open up our Variable Explorer, you'll notice with this code, check this out, region is now in title case. So what this is instructing Python to do is that everything after this str is we're going to apply everything after this str to every string value in the region column. And we can do the same thing to our admission type column. So we'll type admission type equals data 2428 admission type dot str dot title. And if we run this and look at our data frame again, you'll see that region and admission type are both now in title case. A common question I get is, what happens if we don't use this equal sign? So what if we just type this, data 2428 admission type dot str dot title? Well, let's try running that and see what happens. Notice how in our data frame, admission type is still in uppercase. That's because that equal sign is assigning, so this equals assigns the changes that we make back to our original data frame. Okay, so now we've converted these two columns to title case. Now we're going to do the final bit, which is to strip out the first two and the last two characters from our fiscal year. So how do we do that? Well, we're going to write another line here, data 2428, fiscal year, equals data 2428, because we need to assign the result back, dot str. Now things are going to get a little strange because we're going to use square brackets. And what are we going to put in these square brackets? Well, what we can do is use string slicing. So in other words, we can say where we want to start in the string and where we want to end in the string to slice up that string. What do I mean by all this? Well, let's take a look at a string in a little bit more detail. So a string is basically an ordered list or an array of individual characters. You'll see in this example, USAS : coding with a space. These are all just individual characters strung together. Now, strings and arrays in Python all start at index 0. So the first item in our string, the first item in our array, is at index 0. And to do string slicing, we first tell Python where we want to start our slice, and then where we want to end our slice. Keep in mind that it will not include the end slice. So if we say 1 through 5, Python will give us back characters 1, 2, 3, and 4. Let's try that right now. So the way that we slice our string is we say what index we want to start and what index do we want to end. So we're going to say stir 2:6. And if we run this and take a look at our data frame, you'll notice that we've sliced off the first 2 characters, kept the middle 4, and sliced off the last 2 characters. Our data frame is almost ready for analysis. Again, except for this count column. Now, what's going on with this count column? Well, pandas can store all kinds of data types inside of a column. To see what data types are actually stored inside of a panda's data frame, we're going to call a function called print. Now, print will print whatever you put inside the brackets to your Python console. So I'm going to say data2428.dtypes. And I'll run this. And you'll notice that our data frame has 4 columns that are all of type object. Why is that? Because we've got a bit of mixed data going on. So Pandas has interpreted some of the items in count as numbers, but some of the items as strings. And in fact, our data file has an extra row which actually contains numbers as well. So in order to tell Python and Pandas how to treat this count column, we're going to need to convert the values in count from whatever they are right now, strings, into a numeric format. So how do we do that? We're going to do that. We're going to try to do that this way. We're going to say data2428 count is equal to pd.toNumeric, and we'll pass this function the count column. Now let's try to run this. And you'll see in our console we get a big ugly error. But the most important bit is this line here. Unable to parse string 6,800 at position 0. What just happened here? Our toNumeric function does not know how to deal with this comma. Now, we as human beings, we can look at this count column and go, that's a number. That is the number 6,800. However, if you're in North America or any place that uses the comma as the thousands separator, you'll know that this is 6,800. If you're living in a region that uses the comma as the decimal separator, you might interpret this number as 6.8. Two very different interpretations. Pandas is making no assumptions. If it can't directly convert this to a number, it gives up right away. So how do we help Pandas convert this from 6,800 into the number 6,800? Well, we're going to do it through some string manipulation. So check this out. We're going to clean up our count column by using the string accessor again. So we'll do data 2428, the count column is equal to data 2428 count .str.replace. And we're going to say we want to replace the comma with an empty string. Now let's try to run pd.toNumeric. We'll try to run this whole file. No errors this time. Let's open up our data frame. Check it out. Now we've got the column highlights. So we can see where the largest value is, where the smallest value is. We have a numeric column. And because we've kept line 24 in, we're still outputting this cleaned file to a brand new CSV. Let's take a look at that CSV now. Check out our fancy new CSV. It's got our renamed headers. It has our fiscal year column cleaned up. We're using title case. And check it out. We have a number. No more commas, no more numbers in quotation marks. We have a bona fide number. We could read this file back into Python and read it out all day long without having to do any more cleanup on it. So let's review what we've actually done here. First, we cleaned up our region and admission type columns by turning them into title case. Next, we use string splicing to modify our fiscal year column. Then we combined our string cleaning technique with a new technique to convert our column to a numeric value. We ripped out the comma from our count column and then used pd.toNumeric to convert our string value into a number. And then finally, we wrote all of that back out to a CSV file. Plus, we got to learn about data types, that we have strings and numbers inside of Python. And when Pandas can't figure things out, it just shoves everything into object. Next time, we're going to do some more advanced cleaning. We're going to look at a second data file, and then we're going to look at some of the more nuanced decisions that you'll need to make as a data analyst. See you then.